I'd like you to visualise a flat landscape somewhere in the English countryside. Suddenly, out of this flat landscape rises a hill, 300 metres high. That's about the same height as the new Shard skyscraper in London. And let's say the base of this hill has a diameter of about 500 metres. And the amount of earth contained in this hill would be roughly equivalent to the amount of contamination in the land around the Sellafield nuclear plant in Cumbria in England. This contamination is largely a legacy of the early days of nuclear power in the 1950s and the 1960s, and includes a threat to groundwater and to rivers. But what are the specific contaminants? And what hazards do they pose to human health and to the health of the environment? And one way of answering these questions is to regularly monitor the land and the water. But at the moment, this is a very costly process involving sending an engineer regularly to the site to take samples. So I'm developing a system that will automatically monitor at least one specific contaminant, but at a significantly lower cost. Now sometimes the problems found in nature, the answers to those problems could be found in nature itself. Near a small town in Germany, amazing bacteria has been found that lives in mining waste and incorporates uranium into its structure, has a high tolerance for uranium. And uranium is potentially one of the contaminants at Sellafield and sites like it. And colleagues of mine were able to build a tiny sensor about 400 times thinner than a human hair. And this sensor can be used to measure the amount of uranium in water samples. The system I'm developing will deploy this sensor to the real world, to real contaminated sites. And the system will be controlled remotely from a base station and will automatically take water samples and measure the amount of uranium in them. So where does this leave our metaphoric hill of contamination that we started with? Well, with my system, we're able to, for the first time, to be able to continuously monitor at least one specific contaminant in these areas. And secondly, by automating the process, we'll save costs, and money that is currently used for monitoring contamination can be used instead for cleaning up sites like the land around Sellafield, thereby potentially reducing the size of our hill of contamination. Thank you.